Welcome to Study Loop.
So for question A, saying the potential energy U equal to half kx squared. So this is a form of a parabola. So U, it should be something look like this, right? So here is 0, and you can add some numbers based on this equation, okay? For question B, what's the amplitude? So we know the total energy is the energy that given in the question. So it's going to be equal to 0.14 plus 0.06 is equal to 0.2 joule. So when the object reaches amplitude, all the energy are potential energy. So half Ka squared equal to E, right? So from this equation, we know that amplitude can be calculated by 2E over the spring constant. Take the square root. Plug in the numbers, we can get that is equal to 0.2. For question 3, so when the kinetic, so the potential energy is only half of the amplitude. So U is equal to half K, half of the amplitude square is equal to 1/4 times the total energy. So equal to 0.05 D. When they are equal to each other, the potential energy is only half of the total energy. So U equal to half E, right? And it's equal to half kx squared. So from this relation, and we know that E is equal to half Ka squared, we know that x equal to A over square root 2. So the last question. So since the initial kinetic energy and the potential energy are given here, right? So we can calculate what's the initial velocity is square root 2 initial kinetic energy over m. Initial position is negative square root 2 0 over k, right? This negative sign is because the initial displacement is negative, which is described in the question. We know the initial velocity, the initial position, which can be calculated by given numbers. So we know that the position is amplitude times cosine omega t plus phi, right? So the initial position is when t equal to 0, you have the phi here. And v similarly is equal to negative omega a sine phi, right? So also, we know that the angular frequency is square root k over m. So we can also replace this omega by square root k over m. Right? So now we use, this is equation 1, this is equation 2. We use equation 2 to divide equation 1. So 2 divided by 1, we can have the tangent phi is equal to negative v naught over omega x naught. And we're plugging the expression here and here and get it. It's just simply K naught over U naught. So it's just simply the initial kinetic energy over the initial potential energy and take the square root. And it's equal to square root 0.429. So tangent phi is equal to this number, and half phi is equal to 3.72 radians.